All right, sorry, I cut the last video short. I need to help another teacher out with something. But yeah, let's continue on. Well, honestly, it probably works out for the best anyway, since that video was getting kind of long. So, organic chemistry part 2. Let's continue off propene. Propene, what we're doing here is prop, metheth, prop, 3 carbons, ene, double bond, and so we can draw that like this. So we got 3 carbons. And then I didn't put the formula here because basically what I want for us to do is to say, okay, well, we know there needs to be a double bond, and so I'm going to put that double bond here. Now, technically, you see that if I put the double bond here, or if I put the double bond here, right, there is no difference, right? And in fact, right, if I take this, and this requires you to think spatially a little bit, but basically if I flip it, they still have the same molecule, right? Like the flipping of this, if you think in terms of geometry, is it looks like this. And that's the same thing, right? And so, so if I draw it like that, right, it's the same thing. All right, so now we got a double bond here, and so now I'm gonna finish off these to give them 4 bonds. 1, 2, 3, 4. That's good. 1, 2, 3, 4. That's good. 1, 2, 3, 4. That's good. And so that's what that looks like. Now let's do the same thing here. And so there you go. That's what propene looks like. Now how that will look like in a bond line drawing is, I actually think about it like this. I first draw out my 3, and then I just put a double line there. Sorry, let's do that again. 1, 2, 3, and then double bond. Or if I was to draw it this way, like that, right? So there you go. That's propene. Let's keep going. Butene, meth, eth, prop, bute. That's 4 carbons. Ene, again, that means double bond. And so here, 1, 2, 3, 4. And, oh, sorry, before I put on the hydrogens, I need to put on the ene, and so I need to put on the double bond. And so I'm going to put that here. Now, technically, right, do you see that I could have also put it here, right? Or also, actually, I could put it here. But the problem is, this is different than these two, because this and this are just if I was to take this and flip it, right? And again, what I mean by flip is like take it and do that with it, right? So if I was to take this and flip it on its side, I would get this. So those are the same thing, but this isn't. This actually, the double bond is between these 2 carbons. The double bond is in the middle rather than being off to the side. And so this is why actually here, I need to specify, and I do here, I call it 1 butene. What I'm saying is the double bond is on the first carbon. And so what we need to start doing now is we need to start numbering our carbons. The carbons in our chain, we need to say, okay, this is 1, 2, 3, 4. Now you might be saying, why is this 1? Why isn't this 1? Well, that's actually fine. You could say this is 1. And so there's that ambiguity again, right? You could do it that way. It doesn't really matter. What you can't do though is you can't say, I want to start with 1 here, and then 2, 3, 4. You can't do that. Okay, that's not acceptable. It doesn't work like a clock, right? Where it's like, oh, I can reset here. Like, no, you have to start off in a line, right, like this, and then number it. You can start at the left, you can start at the right. It doesn't matter, right? And so 1 butene means that you have the double bond on the first carbon. So 1 butene, double bond on the first carbon, hydrogen. There you go. And so now 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And so there you go. Or we could do 1, 2, 3, 4. 1, 2, 1, 2. There you go. And so just to draw it out a little bit more cleanly for you guys, I'll draw it out again here. Put that here. And so there you go. That is 1 butene. Okay. Now, what is the formula here? I'm sorry, I forgot to do it up here, but 1, 2, 3, 4. 4 carbons, and then 1, 2, 3, 4, 5. Sorry, it's kind of hard to read. So let's actually count it here. 1, 2, 3, 4, 5, 6, 7, 8. C4H8. And let's do it here. But what you can see is it's easier, right? It's just counting carbons and hydrogens. 1, 2, 3. So C3. 1, 2, 3, 4, 5, 6. C3H6. And so what the bond line drawing looks like is just think 1, 2, 3, 4, 3, and put a double bond here. Or very technically, sorry, you could start it off with, and put it like that. So either way it would work. Or sorry, I guess, like that's okay. Or I guess you could also even draw it like, there's multiple ways to do this, do you see? There's also multiple wrong ways, but these are all acceptable. All right, okay, so now we're gonna go on to 2-butene. And so 2-butene, right, what we can see is it's the same thing as before. 4 carbons, we have a double bond. But now the double bond is gonna be on the second carbon. So on carbon number 2, we're gonna put the double bond. And so here we can draw that. And on carbon number 2 this time, so if we number these 1, 2, 3, 4, we're gonna put on carbon number 2. And so this was the one where I showed you, I'm like, this is not the same thing, right? This is 1-butene, this is 2-butene. The one that I said don't do it for 1-butene, because yeah, it's 2-butene. And so now we can do this double bond and make sure everyone's happy. And so there you go. That is 2-butene. Now what would this look like in a bond line? Well, do it like that, and then you can put the line there. Could you also do it like this? Yeah, that's also acceptable, right? And so there you go, that's 2-butene. Now what's the formula here? Well, we got 1, 2, 3, 4, C4, 1, 2, 3, 4, 5, 6, 7, 8, CH. Oh, what? These are the same thing? Yeah, they are the same thing. This actually has a special name. These are what we call isomers of one another. And so you will learn that one day. I don't care with this class, but yeah, they're isomers of one another. They're basically 2 ways of, they're molecules that have the same formula, but structurally are different once you get into it. And so, yeah, so that's also C4H8. Pentene is here. We're going to do pent 5 C's ene. That means a double bond. And this means on the second on carbon number 2. Right. So 5 C's. 2, 3, 4, 5. And here we have 1, 2, 3, 4, 5. All right, on carbon number 2, we have a double bond. Everywhere else, we have single bonds. And so we get something that looks like this. What's the formula here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have C5H10. And so what this looks like is 1, 2, 3, 1, 2, 3, 4, 5. And we're gonna put the double bond here. We could also draw it out like this, either way. Right, I could have drawn out it here, right in that way too, but you know, I think you guys are getting the point. Don't want to bore you. So, all right, meth, eth, prop, 3 carbons, ine, triple bond. And so what's that gonna look like? Well, we got 2, 3. Sorry, meth, eth, prop, yeah, 3 carbons. There's a triple bond. Oh, okay, yeah, so, and so the way this is gonna look like is we're gonna put a triple bond here, and then we're gonna put hydrogens here. Oh, and then this already has 1, 2, 3, 4, right, so it doesn't need anymore. And this has 1, 2, 3, so we're gonna just put it here. Now the reason why I second guessed myself and I was like, wait, not that probe, was because I was like, wait, there's ambiguity here. And why is it not telling? And that's the reason for that is because, yeah, I mean, it doesn't matter, right? If I draw it like this, is that the same molecule? it is the same molecule, right? All I'm doing is I'm taking it and I'm flipping it on its side. So yeah, just take it, flip it, it would be this. Like they're the same thing, right? So how we would draw this is actually for, you could, I mean, for this class, I'm okay if you do this. But technically that's actually not how you do it. Actually, whenever we have triple bonds, for some reason, they don't point anymore. I mean, there are structural reasons for that. Basically, the reason for us not doing that is the structure of the molecule. You can't bend triple bonds. And so, yeah, that's why it doesn't flex like that anymore. And so here, actually, when I've been doing this, actually, I should have been showing you more of the angles, but this is a basic course in, or basic lesson on organic chemistry. You don't need to know all that. So, all right. And so those are your 3 carbons. And so there you go. Or if you wanted to, you could do it like that, and you still have 3 carbons. So there you go. All right. And so, let's see. Yeah, let's just go through functional groups really quick and show you guys an example. I realize that going through every single one of these has resulted in a very long video, but I know organic chemistry can be confusing, and so I want to make sure that you guys have as much support as necessary. So, all right, here, basically functional groups, they're kind of like decorations of sorts that you can put on your molecule. So far, right, we've just been using carbon and hydrogens, but there's other things that we want to put on our molecules, and these functional groups actually give our molecules properties. They start to make it things that are useful. Functional groups are what make medicine, for example, or what make aspartame, which is the compound. It's like an artificial sweetener. It makes aspartame different than a sugar, which makes it so that it's indigestible, which makes it so that we can have things like Coke Zero or Diet Coke, which not very popular in the States, but in England, they love it. So I don't know why I have England on the break today. But the point is, these are actually very important functional groups. They make life more fun. They make molecules more useful. And so a halide basically is where we have a group 17. And so what that looks like is, for example, propyl chloride, what that means is you have propane, but then we add a chlorine onto it as kind of a decoration. An alcohol is when we have an OH. And so, again, what we have here is pentyl alcohol. We have a pentane, and then we added on an OH to the end of it. An ether is basically when we have chains of hydrocarbons. The R's are chains of hydrocarbons, but then we have an O in between. And so stuff like this. This is what we call ethyl methyl ether, because we have a ethyl here, there's 2 carbons, and then a methyl here, and then we have the O in the middle. Carboxylic acid is COOH. It looks like this, COOH. And here's our hydrocarbon group. And so if you have a hydrocarbon with a carboxylic acid added onto the end, yeah, this is butanoic acid because meth, eth, pro, but, 4 carbons, 1, 2, 3, 4, 4 carbons. And then we add on then we have the acid group. Ketones are, they look like this, carbonyl groups, CO, and then we can have the chain here. And so, and technically also actually you can just put like a hydrogen instead of the hydrocarbon chain. And so here, this is formaldehyde, the drug that knocks people out. And so it looks like this. It's a carbonyl group and then attached on with the hydrogen. And then lastly, we have esters. Esters are COO. And so we have a chain here, and then we add on ester group. Actually, we also have another chain here. But yeah, here's an ester group. And so got to learn my next class. And so I'll finish up showing you guys what functional groups look like in a part 3 and final video.